Hello. 1, 2, 3 testing. I don't like Sundays. I don't like Mondays. Tell me what. Anyway, right. And you start. It's very difficult to do it with you here. If I'm being honest. Right, I'm just going to demonstrate just how incredibly easy it is to use this software. So, I've got a drawing here of a first floor precast concrete beam and block layout, and this wall just here. There is no wall just here below, so we need to design a beam to span from there to actually support this floor. So firstly, we open the load section of the program. As you can see, it's got loads of, well, loads, yeah. It's got lots of standard loadings in for various configurations and what have you. And it's so easy to set up loads that you use all the time to make them your favourite loads, so that when you're doing a design you can say, okay, well, that's a beam and block floor, it'll automatically put the loads that you want in there. If it was a timber floor, it put those loads in there. If it was a 100mm thick internal wall, it would do that, and I'll just show you quickly how you do that. You just select the loads that you want, depending on whether it's a wall or a floor or a roof or a pitch roof, and then you go add to favourites, and let's call this rubbish. And then if you look at your favourites now, you've got rubbish in it, and if you want to, well, yes, it's full of rubbish. If you want to delete it, then you just right mouse click on that, click rubbish to delete, and it's gone. So as I said before, this is a precast concrete floor layout, so we're going to look for a precast concrete beam and rock floor. So that's all we need to do. The loads are worked out. We export that into the project loading section, and you'll see it's actually exported all these values across here. Now the only thing that we need to do is to actually decide on what's called the length there, the length of structure that's actually contributing to that load. So it's fairly obvious that if that's a beam there and these precast concrete planks are spanning from there to there and from there to there, that halfway between there and there, that half of the floor will go onto there, and the same on this side as well, that half that load's going to go on the floor. So if we said, just for the sake of example, that was 5.3 meters, that was 4.2 meters, so if we said that was 9.5 meters, then half that distance will be 4.75. So basically we just type in 4.75, and then we calculate that, and that's actually worked out all the loads on the beam in terms of UDL. So now we want to design that beam. Actually, this little button here, you can select that or deselect it. If it's selected, then and you enter a length in there, it will reproduce that for everything. But if for whatever reason you want to put a different value in there, just deselect that. Right, so we've calculated it, so now we export it into the analysis section of the program. We've already had one in there, so I'll just delete that now. Do you want to delete that load? Yes. So basically you can see that the loads from here, 26.6 kilonewtons dead load and 7.3 kilonewtons live load. I've obviously just deleted the wrong one, it should be 7.3, but anyway, for demonstration purposes it doesn't really matter. Right, so to actually calculate this, you just click the calculate all, and that will show you that the UDL loading that we've got, shear force diagram, bending moment diagram, which is just part of the design process, but you don't need to worry too much about it, and the deflection of the beam. Now a little explanation of this here, you'll see this little loading button here. We've taken that as a uniform load across the whole length of the beam, but if you've got a different type of load, like a point load from a beam sitting on top of that, or even a triangular load, if you look at that easily, you'll see that if it's a triangular load, you know, the load increases from one section, from one end of the beam to the other. Let's stick this back as a uniform load, recalculate that, get the forces again, Obviously if you want to add additional loads, then you use the same procedure to do that. And then if we want to actually design the beam to support that, see this little thing pops up there, and basically if we're using a universal column section, we'd need a 152by152by51, not a popular section because it's an unpreferred size, so we just go up to 203, 203, 46, and you can see it passes all the checks here. Alternatively, if you wanted to design a universal beam section instead, you just select that in the box there and it'll come up with an appropriate section. So that's it, beam designed.